So we have to evaluate the integral of dx upon x times x squared plus 4. Now it's very obvious that in a problem like this we need to use the concept of u substitution, but it's important to be mindful as to what you're substituting as u, because if you take a random part of a function like for instance x as u, then it's just going to be du upon u times u squared plus 4, which is basically where we started. So we need to kind of alter it or algebraically manipulate it in such a way that we directly connect the function to the derivative and use the concept of u substitution more efficiently. So how would we do that? Well, dx and x though are useless, they're basically just sitting there doing nothing, so we need to make use of this x squared plus 4. There's definitely a reason as to why it's there. So what we can do is we can factor something out. If we take 4 common, this will be x squared divided by 4 plus 1. That will be a very complex function, but that will not be connected to this. This will be 4x. That could be the function or the derivative, and this could also be the function of the derivative. And dx, so we can isolate, form another equation. That's basically the idea. And that will happen anyways because we are differentiating with respect to x. So if this is I, basically what I can do is I can rewrite this as the integral of dx upon. Now, instead of factoring 4 out, why don't I factor x squared out? Because this will become x cubed then. X cubed. Now to factor is basically dividing each term by what you're factoring by. So this will be 1 plus 4 over x squared. So now I can directly take u is equal to 1 plus 4 over x squared. This looks like it can be connected to this. So if we differentiate this, derivative of 1 is 0 because it's a constant, and 4 over x squared can be written as 4x raised to power negative 2. Using the power rule, this will become negative 8x raised to power negative 3, which is just negative 8 over x cubed. So du upon dx is basically just going to be negative 8 divided by x cubed. So now, as you can see, we have dx here and we have x cubed here. Similarly, you have dx here and x cubed here. So we successfully connected it. So now we get them together. If we cross multiply, dx over x cubed is basically going to be equal to du over negative 8. And that's what we're going to do over here. So in place of dx over x cubed, we're going to add du over negative 8. And then this though we have taken as u anyway. So this will be u, right? And now since negative 8 is a constant, can't be integrated, we take it out. So this will be 1 over negative 8 or negative 1 over 8. This will just be du over u. So now we basically have to integrate this, right? Integral of du upon u is just going to be log u, natural log of u. So this will be negative 1 over 8 natural log of u plus obviously the constant of integration. Now what had we taken as u? Initially we had taken 1 plus 4 over x squared. So it's going to be negative 1 over 8 natural log of 1 plus 4 over x squared plus c. And this is going to be the answer.